something important to note. You ask, well, why do I want all this holster below my belt line? Isn't that going to be uncomfortable, right? I want as little gun and as little holster as possible because that's intuitive to me as obviously more comfortable and more concealable, right? There's an element of that that's actually counterintuitive. So let's talk about this principle real quick. Right? Art school. We've got a boat in the water. Look how much boat is underneath the water compared to how much is above the water. Wind comes along and the boat tips over in this direction, right? That's because it doesn't have a keel. If the boat had a keel which extended below the water, the wind would come along and the keel would resist the rotation or the tilt, and the boat would stay upright, right? When the mass or leverage above the waterline is greater than what's available to resist it below the waterline, the boat's going to tip over. Now, let's take this same principle and apply it to small concealed carry pistols. Here's our wee bitty gun, right? We've got somewhere between 8 and 10 rounds in this magazine, and the belt line is here. The mass of the gun above the belt line dramatically exceeds the mass of the gun below the belt line. So if we're looking at it this way, and here's the body with the belt on and the amount of gun above the belt line, what's going to happen is that the top of the gun here is going to stick out, and these parts of it are going to print. And then the bottom is going to rotate inward, and then all the mass above the belt line, all that pressure is going to get focused here and give you a hot spot here on your body. Now, what do we do to fix that? Well, what a lot of us are doing is building holsters that are a little bit longer than the gun itself. And that creates a keel which resists that rotation, especially if you install a wedge of some kind on it. Now your tiny little gun is more comfortable than it was otherwise because any amount of force that's being generated by this rotation is dissipated across a larger surface area. Matt Jaques calls that the Lego principle. When you step on a Lego, it hurts like shit. If you stepped on a Lego that was the size of a phone book, it wouldn't hurt at all, right? You are spreading that pressure across more surface area, which is why a Glock 17 is more comfortable to carry than a Glock 26. But if you put a Glock 26 in a holster made for a Glock 17, you're reducing all of the grip that could potentially print, reducing the mass overall, so you've got less weight and pressure to be applied to your body, and you're spreading all of that out in an area the size of a Glock 17. So you get better concealment and more comfort. That's the Keel principle and the Lego principle in one lesson.